on this computer. All right, welcome everybody to the inaugural for the first Knox Summer Science Seminar for 2021. Professor Bundy, who is usually in charge of these, could not be with us today. There is a dental appointment that he forgot about, and so I'm here all by myself in this beautiful classroom. I'm waving at all the empty chairs. The purpose of this particular talk today is not for you to learn what I'm talking about. It's for you to see a presentation and for you to critically evaluate it and taking that evaluation to your own presentations in the future. So for instance, answer such questions as, what did I do well? Or what did I not do well? And then when you write those down and you have your own presentation in the future, you'll know what to do and what to avoid doing. So that's the real purpose of a faculty member giving the first talk of the summer. Theoretically, these are going to be every Friday morning, same time, same place, until sometime in August, I believe. But don't know that since I'm not Professor Bundy. So I will now switch over to my slides. I will test my little clicker thingy. Hey, it works. I'm surprised. Just as a heads up, I've got my laptop here. It is labeled chat here. So if you have questions during the presentation, please leave it in the chat for chat here. I don't know, I can't see the chat now. Okay, meeting's being recorded, chat. Yeah, I've only been using Zoom for a year and a half. I don't know it yet. I think they just changed things. And I will see your question, comment in the chat, and I'll decide if to break in and answer it immediately or wait until the end. And we have a kitty cat, so that's fantastic. What is the kitty cat's name, Rick?
This is Motor. She is my grad school cat, and she sat through all my dissertation writing with me on my lap.
Oh, wow. Smart cat. In theory. Okay, since I'm working with two computers, I will be making mistakes, but let's see if I can figure this out. So the title of today's talk is Testing Turkish Democracy. This is an application of electoral forensics, which kind of marries the idea of the ideas that are in political science with some of the ideas that are in statistics. Eventually, and the final goal for today is to be able to interpret this graph. And I'll give you some pointers of what's on this graph. There's dots, there's numbers, there's lines. That's all that's on the graph. Each of those dots actually represents a province in Turkey. The vertical position is the invalidation rate in that province, and the horizontal is the support rate for the AK party. So the goal is for us to be able to interpret this and to understand what it's trying to tell us. And for two of you who are in my research group this summer, you know exactly what these dots mean and what we're trying to learn by looking at them. So we're going to start with talking about what an electoral democracy is. That'll lead to something called differential invalidation. And we're eventually going to figure out some ways of testing differential invalidation. Those ways will be using some sort of regression test. I'll cover the classical linear model, the generalized linear model, and then ultimately end up with the vector generalized linear model. Don't worry about the mathematics underlying any of those. It's beyond the scope of this course. Then we'll start laying out the political science for understanding why we're testing this and what we want to get out of it. We're going to look at 3 constitutional referendums that were put forward by Erdogan, the current president and then prime minister of Turkey. And then we're going to analyze the data using graphs just like we saw in the beginning, for before Erdogan's reforms and then after his reforms, and see if there was any effect of those reforms on Turkish democracy. And then discussion and conclusion. So let's jump in. We've got to lay out what we mean by an electoral democracy, made up of two words, one electoral, one democracy. Everybody knows what democracy is, except none of us know what democracy is. In many ways, it's like pornography. We know it when we see it. If you read through the literature on democracy, you'll find out that there are many conflicting definitions for it, but they all seem to center on one idea: one person, one vote. Everybody's vote counts the same. So here's three things that are written about electoral democracy, or definitions of it. The Democracy Web says it's a means for the people with equal political rights as citizens to choose their political leaders in regular, meaningful, free, and fair elections. ACE says the utilization of electoral processes would be voting things, to decide which citizens will be entrusted with the basic tasks of government. All citizens will have been able to intervene in that political decisions by means of representatives elected by universal, free, equal, direct, and secret suffrage voting. One person, one vote. And then US aid. A country cannot be truly democratic until its citizens have the opportunity to choose their representatives through elections that are free and fair. And all three of these talk about free and fair. And that's the cornerstone of an electoral democracy, something that all the definitions agree upon, although the definition of free and fair is rather fluid as well. Political science is awesome. So we'll go with, amongst other, fair election ensures that each person's vote has the same probability of counting, irrespective of who the person is or who the vote was cast for. Irrespective of who the person is, that is, who the voter is, or who the vote was cast for, or which position it was cast for, has the same probability of counting. None of the other definitions mention probability of counting, so I had to throw it in here. And here's why. When you go to the ballot box to cast your vote, you fill it out by hand. In some jurisdictions, you still fill it out by hand. And you could actually fill it out incorrectly. You could accidentally, or maybe on purpose, spoil your ballot. And when the person who counts all the ballots comes across yours and sees that it's spoiled, filled out incorrectly, they will throw it out because it is not a properly completed ballot. They will invalidate that ballot. Totally legitimate process. The only problem comes in when the person invalidates a ballot simply because it was filled out for the wrong person or filled out by the wrong type of person. So we need to figure out some way of testing for this differential invalidation. And it's called differential invalidation because it talks about the invalidation of ballots. And it's differential invalidation because it's looking for evidence that certain people have their ballots invalidated at a different rate than others. So here are the consequences, and this is what we'll hang our regression tests on. The proportion of ballots invalidated in the division must be independent of the proportion of ballots cast for the candidate. There can be no relationship between the invalidation rate and the candidate's support. If there is, then that's prima facie evidence for differential invalidation, and that's unfair at the very least fraudulent, perhaps. And the only, or the set of statistical techniques that we have available to test for relationships between two numeric variables is called regression. And there's a lot of different flavors of regression. We'll cover 3 of them. We'll start with the one that's introduced in Stat 200, and we'll move on to the one that's introduced in Stat 225, and then we'll move on to the one that's probably the best of the 3. And the really cool thing is if you're actually doing this analysis on a computer, all 3 are about as easy to do as any of the others. So we'll start with regression methods and the classical linear model. We start with the model y equals xb plus e. Y is the dependent variable. X is the independent variables. B is the vector of coefficients we're trying to estimate. And E is that remainder, that residual, that quote error. And actually all 3 of these have that as the class, as the model itself. So here's OLS. It makes the assumption that the y's, the dependent variable, follow a normal distribution. Well, technically, it's the y values given x follows a normal distribution. It's a rather restrictive assumption, but we do it because it really makes the math work easily. We've got something called a linear predictor. That's the mx plus b part, the beta naught plus beta 1x part. That's the relationship between the 2 variables. And then to frame it in a common sense, we got to create this thing called a link function. This link function in general is a function that relates the linear predictor to the expected value of y. So when you do OLS regression, what you're doing is you're plotting a line or finding a line of those expected values. The general way of fitting this, although it's not the one that has to be done, is ordinary least squares. If your dependent variable is constrained in some way, such as ours, remember it's a proportion, our dependent variable is a proportion. It's an invalidation rate, so it's bounded between 0 and 1. So it is constrained, so we could do a transformation. And the really cool thing about OLS, even if you violate some of these slightly, it's still a really good method. It'll come really close to the correct answer, even if these assumptions are violated slightly, as long as you've got enough data. But it does require that the distribution of y is normal. And it does have just a linear predictor directly connected to that expected value. In some ways, that is rather constraining. So we invented something called the generalized linear model. Notice the changes between the 2. I'm going to flip back and forth between these 2 slides just so you can see the changes. Boom, 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 boom. Not much changes. I think the key changes are in the conditional distribution. No longer does y have to follow a normal distribution. It could be any distribution whatsoever. Well, not any. The distribution has to be a member of the quote exponential class. And 2, the other change was the link function. The link function could be almost anything you want it to be, anything that makes sense for the problem. I do want to draw your attention to the fact that the generalized linear model actually subsumes the classical linear model, because the normal distribution is a member of the exponential class. So you really don't even have to do OLS. You could jump all the way to generalized linear models and still get the same benefits. But there still is a limitation here. That distribution, that conditional distribution, has to be a member of the exponential class. There's a lot of those distributions. The most common ones belong to that. And two, you fit it using maximum likelihood instead of least squares. So instead of minimizing something bad, you maximize something good. And the likelihood is just the probability of this model giving you the data. It's a different way of looking at what you should optimize. Now, the newest addition to this is called vector generalized linear models. VGLMs extend this a little bit in that you no longer have to have a probability distribution that is a member of the exponential class. And this is the one that we're going to use because of the following reasons. The invalidation rate itself is actually discrete. It's a discrete count divided by a discrete count, so it's discrete. But we're going to model the counts themselves. And those counts are going to follow some type of binomial distribution. Turns out binomial is a member of the exponential class, so we could do generalized linear models. But the problem is with election data, with voting, like people tend to live near each other. It's a clumping problem. It results in what's called overdispersion, and it really means that the distribution of y, the conditional distribution of y, is really not binomial. It's something like binomial. It's an overdispersed type of binomial, but it's not binomial. And what we are going to use is what's called a beta binomial. But we can't fit beta binomial because it's not a member of the exponential class, so we have to do vector generalized linear models. But again, in the computer, to run linear models in R, it's 2 letters, LM. To do generalized linear models, it's 3 letters, GLM. So not much, it's 50% more typing of the command. And for vector generalized, it's VGLM. So the actual work that we as analysts put in is not that much more. 2 more keystrokes. And we get so much more out of it, so much more flexibility. So it's this vector generalized linear model that we'll be using. And again, I do want to emphasize, it is fit using maximum likelihood, but again, the math is beyond the scope of this course. I love that phrase. So now we move in the political science part. Erdogan took over as prime minister in 2003, I believe, 2002? 2002. This was his first of 3 constitutional referendums. This particular referendum made it so the president was elected by popular vote. Before this, the president was elected by parliament. So now Erdogan thinks that it's better to have the president elected by the people. Term of office for the president is reduced from 7 years to 5. However, the president may now stand for a second term. In terms of the parliament, the elections are held every 4 years. It used to be 5. So it brings the parliament closer to the people. And the quorum required is reduced from 67% to 34%. So this was the first of the 3. It passed. The second of the 3, the deputies remain in their posts until the end of their elected term. The number of members of the Constitutional Court goes from 11 to 17, so there's 6 more members. Previously, the members of the Constitutional Court were all appointed by the president. With this change, with this constitutional change, the president and the parliament appoint members. While the president still appoints 14, the parliament does get to appoint some of them. And these are appointed. And the new court members have 12-year terms, or until they reach retirement age. This also passed. Not as much as the first one, though, which is kind of interesting. And the third constitutional referendum, which was 2017, raised the number of seats in parliament from 550 to 600. So again, made the parliament much more representative of the people. Lowered the age requirement to stand as a candidate from 25 to 18. Individuals with relation to the military could not run for election. Turkey, like many of the post-Ottoman states, the military always saw themselves as the ultimate defender of the Constitution. And how that appears is several times during Turkey's existence, the military has stepped in and performed what outsiders refer to as a coup d'etat, but that the military sees as just protecting the Constitution. So in this constitutional change, Erdogan is trying to separate the military from the government a bit more. Parliament and presidential elections held the same day every 5 years. Presidential elections are a two-round system. If in the first round nobody gets 50% plus one of the vote, in order to stand as a candidate, individual requires endorsement of one or more of the parties that won enough votes in the elections, plus 100,000 voters. So if your party didn't get more than 5% of the vote, you can't put forward a presidential candidate. And now the acts of the president are subject to judicial review. This is something that was lacking in the Turkish constitution before then. It's very much like what the United States has. We have judicial review, not only of the presidential actions, but of the parliament's actions, our Congress's actions. So those were the three constitutional referendums for democratization. Let's see how it changed Turkey. I don't like that slide. We'll look at pictures now. So this is the general election in 2002. This was before all three of those reforms. This is the support for the AK party. Darker indicates higher levels of support. I do want to draw your attention to a couple things. I'll just draw your attention to one thing. Over here on the, I don't know what part of the country this is that east? Over here in the east, not much support for the AK party. It's kind of interesting that over here in the east, that entire light green part, that's also a very strong Kurdish area. Here's the invalidation rates. Darker the province, the higher the invalidation rate. Notice in that same area, that same Kurdish area, much higher than those that are through the center. In fact, if I flip back and forth between this slide and the previous one, you might start seeing some connections between the dark in one and the light in the other. Ideally, there will be no actual relationship between the invalidation rate and the AK party support rate. If there is, then we have evidence of differential invalidation. We have evidence that votes for one party were systematically thrown out more than votes for another party. And that's a no-no. So here's the model specifications. It's actually going to have two models for this. Dependent variable is going to be the invalidation rate, or technically it's the number of invalidated ballots plus the number of, not plus, but in addition to the number of ballots that were cast. From one model, the independent variable is just going to be the support for the AK party. For the other model, it's going to be the support for the AK party and the support for the HD party. Why am I throwing in a second party here? The reason is because the long-standing issue in Turkey is, I'll frame it this way. What do we do with the Kurds? When the modern state of Turkey was first created, Ataturk, who was the president at the time, decreed several things, including everybody who was born in Turkey is now Turkish. Well, that's okay for most people born in Turkey, but those who are Kurds, they want to be Kurdish instead of Turkish. And went so far as Ataturk actually claiming they are actually Turks, they're just mountain Turks. The HD party is a Kurdish party in as much as any party can be a Kurdish party. So why don't I actually use the proportion of the population in the province that is Kurdish? Well, because that question actually cannot be asked on the census. Because according to Ataturk, and throughout the entire history of modern Turkey, everybody there is Turkish. So it doesn't even make sense to ask about being Kurdish because everybody's Turkish. The distribution, or technically the conditional distribution we'll use, is the beta binomial. Since we're using the beta binomial, we have to use the vector generalized linear models. Link function is going to be the typical logit. This is why I'm using the HD party. The title is the Democratic Party of the Peoples. Their platform is explicitly pro-Kurdish. They seek to challenge the current Turk-Kurd divide. It is strongly allied with the Kurdish Democratic Regions Party, which actually cannot run candidates because it's Kurdish. The critics of the HD party have accused them of mainly representing the interests of the Kurds. The HD party participated in peace negotiations with the Turkish government on behalf of the PKK separatist militant organization, otherwise known as a terrorist group. So I'm using this as a proxy for the proportion of the population in the province that is Kurdish. And here's a map of their support. Whoops, too far. Here's a map of their support. Darker indicates more support, lighter indicates less support. And you'll notice that their support is in the Kurdish regions. So on its face, it makes sense to be to stand in for the proportion of Kurds in the province. So that's why I'm using it. So here are the results. And again, these are for before Erdogan's reforms. This is 2002. The first model where we only use the AK support. Notice a couple things. Notice one, the estimate is a negative. The 0.9836, that really doesn't matter. It's not that well interpretable. But the fact that it's negative and the p-value is also very small indicates we have strong evidence that there was differential invalidation in favor of the AK party. The second model, the one that includes the Kurdish vote, we see that the AK, there is still, AK support is still negative and the p-value is still small. So there's still evidence of, even including this Kurdish problem, there is still strong evidence of differential invalidation in favor of the AK party. Not a good thing. Now, it is kind of interesting. I don't want to talk too long about this, but the estimate for the HD support, it's negative, but the p-value on it is very large, meaning there doesn't appear to be any differential invalidation against the Kurds over and above the differential invalidation for the AK party. And of course, we've got this plot. This is exactly the same as the plot in the very beginning, except now we've got a line of best fit. That line of best fit is the model. This is the relationship between the invalidation rate and the AK support rate. Downward sloping. We already did see that it was statistically significant. Now, if we add in the Kurdish part, where the green is the high Kurdish population group, and the red is the low Kurdish population group, we see very little difference between the two. They're still downward sloping, but the separation or the effect of going from a high to a low doesn't really change the invalidation rate that much. And that kind of reflects the regression table we had, because that difference is not statistically significant. So this was before. Strong differential invalidation in favor of the AK party. Not much in terms of Kurdish high to low. So let's move on to after. This is the 2018 general election. Same color scheme as it was for the AK support for 2002. You notice that there's much more support for the AK party. Notice again that the lower right quadrant, the Kurdish area, looks to be a little bit lighter than most of the others. The invalidation rate. Again, we see in the Kurdish areas, it's a lot darker than those that are around it. I'm going to flip back and forth between these two slides just because it's kind of fun. I mean, because it helps us to think, is there any relationship between the two? Is light on one going to be dark on the other? Sure seems to be that way. So here's the model. Same idea behind it. Two models, one's going to be just support for the AK party in this election. The other model is going to be support for the AK party and the Kurdish proxy variable. Still beta binomial, logit. The results, notice the p-value in the first model for the AK support is now greater than 0.05. Indicating that we did not detect differential invalidation in favor of the AK party in this election. In the first election, the 2002 election, we really detected it. I mean, that p-value was essentially 0. Now it's gone. And for the second, again, even if we include the Kurdish level, AK support, nope, there is no evidence of differential invalidation in favor of the AK party. However, note that the Kurdish issue is very strong. But even so, this estimate of support is 0.006977. That's small. Here's the graph of model 1. It's downward sloping, but it's very shallow, and we already saw that it's not a statistically significant slope. Here it is for 2. Notice the gap between the high Kurdish and the low Kurdish is much larger. Note that the high Kurdish population areas had higher invalidation rates. It's because the green curve is on top. And the low Kurdish population zones had lower. Indicates that we do have some evidence of differential invalidation against the Kurds. But we did get rid of that differential invalidation in favor of the AK party. So we made some progress. It is kind of unfortunate because many of Erdogan's reforms were aimed at reducing or eliminating the Kurdish problem. Doesn't seem to have worked that well. So discussion and conclusion. Definition of electoral democracy has their citizens elect the leaders. A necessary but not sufficient. A necessary condition for the election to be free and fair is have everybody's ballot have the same probability of being counted. When the votes are aggregated to any level, to the division level, a free and fair election will have the invalidation rate independent of the candidate support rate. Independent meaning there's no relationship between the two variables. As both variables are numeric, we'll use regression. Beta binomial regression is the most appropriate for modeling this relationship because the dependent variable actually does follow something like a binomial an overdispersed binomial, and a beta binomial is an overdispersed binomial. It is not the only overdispersed binomial, but it is a overdispersed binomial. The political science report results are actually the most interesting for me. So before Erdogan passed his reforms, there was significant evidence of differential invalidation in the overall population and in the Kurdish population. Because remember, even though the difference between the green and the red lines in the first model, first pair of models, was small, it was still downward sloping. After Erdogan passed his reforms, there was no longer evidence of differential invalidation in the country as a whole. However, there is evidence of unfairness against the Kurds in Turkey. Anyone who knows the history of Turkey will not be shocked at that conclusion. Shocked, I tell you. So here are some references and further readings. The data itself came from the government of Turkey. Article and a book on vector generalized linear models. And then the electoral forensics talk. So I will now open this up to any questions. Oh, that's right. If somebody was here, they'd say, okay, a round of applause. Awesome. Now, any questions? Ben, go for it.
Yeah, thanks for this. This is really interesting. I was wondering if, and I apologize if I missed this, but if you could talk a little bit about the potential for serial correlation within the units. I'm assuming that if, or at least I can imagine that if your ballot gets invalidated in 2002, you might become less likely to vote again in 2018. And so there might be less need for invalidation. If there's a minority party and they see that the votes for their party are getting invalidated, then maybe they won't bother to vote. And then the need for differential invalidation from the perspective of the central government is going to go down. And I just wondered if there was a way to sort of estimate the extent to which that could be happening, or whether that's accounted for differently in the model, or whether there's just not a theoretical reason to expect that that would be happening. So I'd just be interested to hear you talk a little bit more about that. Thanks again.
I'm going to do my best to answer that question. What you raise here is a very good point, actually, and it cannot be accounted for given the data that's available to us. What would be necessary for us would be to have more than just the before and after. It would have to be several before elections and several after elections just to see if there's a pattern of decreasing invalidation, differential invalidation, or increasing differential invalidation, or if there's any change whatsoever in the differential invalidation. So that would require more models, more data in order to actually start to tease at that very interesting question. And the last election here is 2018, and so it can't get too many afters. Yeah, so that's my answer.
So Ole,
Yes.
How many parties does Turkey have? Like you've mentioned two of them. I don't know the Turkey system very well.
Turkey is it's a multi-party democracy. It has several parties. I'm going to estimate somewhere around 5 to 6 parties that are nationally prominent. So more than we have, fewer than Italy has. But then everyone's more than we have and everyone's less than Italy has.
Well, so was there a reason you just looked at AKP then, or were there?
Oh,
You could do the same analysis for all of them, couldn't you, or each of them?
I could do the same analysis for all of them. The AK party was chosen because it was the party that was in power in the government. And therefore, if any of the parties were going to cheat, if any of the parties were going to enforce differential invalidation, we'll make it a boring way of saying cheating, then they would be the only ones who would be in position to do that. So that's why I used them. And in fact, the AK party is the party of Erdogan. So yeah, they're the only ones that had the power to differentially invalidate. Was that good, David?
Yeah.
Okay.
I mean, I could still imagine, like, again, I don't know the system, but is there a coalition government or is it just AKP?
It's just AKP. The three big ones, nope, I'm not going to be able to come up with the three big ones. But there's AKP, which is the largest party in parliament. And there's one that's the main a party against them. And then there's the Nationalist Party, which is to the right of the AK party. But the Nationalist, the MHP, is like 5 to 10% of parliament. And I probably should preface that with, from what I remember from a couple years ago. Next question. Bless you. Okay, seeing no further questions, I do want to again emphasize that the main purpose of this talk is for the students and have you critique my talk for your own talks in the future. What did I do well in your opinion? What did I not do well in your opinion? And keep that in mind as you prepare your own presentations for your research this summer. That was the main purpose. So if there are no, Professor Bundy, would you like to say a few words about the summer science seminar?
I think just that we're starting, so we're gonna keep doing these talks. I don't as of last night, nobody had signed up for next week, but hopefully we'll get some brave souls to sign up for next week. And so the idea is we'll have probably 3 students or groups of students each time, so something like 20 minutes. And just, it's a chance to practice presenting. It's a key skill, right? So obviously you have to do it if you're an academic, but even in industry, right, often you have to advocate for what you think people should be doing or what you think is interesting. And so it's a good skill to have and good practice. Yeah. So please sign up if you. I can post the link, but it was also in the email.
All right.
So keep coming.
Okay, thank you, everybody. I wish you a very good Friday, and I'll see a few of you at 2 o'clock today. The rest of you, I hope to see you later. Goodbye. Oh, stop
Well.
recording.